most of the time it will be the pen work. Okay. Start with unit 1, right? And unit 1, if you just check, it's more or less the basic things that we already know about. Okay. So in general, when we talk about, let's say, vectors, okay, we're going to talk a bit about vector algebra now, and we know that okay, vectors and scalars, and vectors are why it's more important, because it's obviously provides me more information. And as we have seen yesterday in classical mechanics, we do understand that vectors did tell me about the direction, okay, the position vectors and so on. And when we consider something like the polar coordinates, the spherical polar coordinates, and so a vector plays a very important role. Okay, so be it in a circular scale or a linear scale, the direction is important. Okay, and based on this, we actually call it as something which is there in mathematical physics, something which you use in classical mechanics, in quantum mechanics, in statistical mechanics, and so on. Okay. So the first thing is, of course, addition of vectors, and if we just go for addition of vectors, let's say, okay, we have to understand certain figures which may be a bit important. Okay, so if I just consider this, maybe this image, okay, let's take up a line. Okay, that's more easy for me. Okay, so you have, let's say, two vectors A and B. If the basics of vectors is clear, sometimes it becomes helpful to solve numeric problem, and that's why I'm just trying to do the basics for now. Okay, my drawing skills are not that good, but I think you'll understand exactly. Okay, so you have a vector here, and let's say this is your vector A, okay, and the other one is your vector B. Okay, so you have your vector A here, okay, and this is your vector B. And then you have got, let's say, a vector v bar here. Okay, and then what you can do is that you usually want to go from one point to another point. Let me say this is your C. Okay, and then maybe you can actually draw some dotted line. Okay, maybe I can just wait. Okay, try to make it better. Okay, this is the one that I have here. Okay, and then this is the one. So this is basically an image that I have here. Okay, and right, so obviously it's not straight. As I said, drawing skills not that good. But then if you just take this up, you can actually consider that this is a vector which is parallel to this, so in the same sense, so this will actually be something which can be used to understand it better. Okay, so we have got the origin here, we have got A here, let's say this is your B, let's say this is your C. Right, so you can go to a particular point using different positions, right? So in general, when I write down V, we can say it is OC, and that's a vector. Okay, and when we talk about OC, we can also go to OC via this line, right? We can go via this, and then we can follow this particular path. So just simply write it down as OA plus AC. Right? So in general, we actually want to represent it. We can just simply say that this is nothing but A bar plus B bar. Okay. So what I will do is I'll usually use the bar sign for vectors. In books, most of the time you'll see it written in bold. Okay, the vectors, and you can just follow this, something which is simpler. Okay. So this is something which is for let's say a two-dimensional or two vectors. Okay, we have just got A and B. Now, in case there are three vectors, let's say A, B, and C, how exactly we represent them? Okay, is something which I would leave to you, and I give it to you as a task. Okay, because this is something which you might have studied before. Okay, maybe I can give this. Okay. Well, I will just. So maybe this is your A. I'll just give some random directions here, and maybe this is your B. Maybe this is your B. Okay, and then I have, let's say, I have a C. Maybe I will make it a bit more complicated. So if you just want to find out the vector addition here, okay, the resultant of vector, how exactly you are going to do it, maybe something which you can try, okay, doing it. And maybe I can just draw it here, okay. This is A bar, this is B bar, this is C bar, okay. So this is just to confuse you, you know, if you just shift it here, you're actually going to have your C bar something like this. You can consider this also. If you just take it from the single origin, you just take it as O and take it as C bar. And then you have to find out what is this vector B bar, V bar. So when you do it, you have to combine it in different ways by drawing the diagonals, okay, or these similar dotted lines, okay. And then finally, when you do it, you will see that A bar plus B bar plus C bar is nothing but A bar plus B bar plus C bar, okay. Or in fact, you will also observe this. This is when you do it, okay, in the right way. You will also observe that this is A bar plus C bar plus B bar. So you can see that this is all more or less distributive in nature. Okay. So in general, when we write it down, we actually see that this is nothing but A bar plus B bar plus C bar. So maybe you can just take it as an exercise and try it out. Minus B bar, okay, is equal to V, or V bar is equal to A bar plus of minus B bar, right? So the vector addition will basically depend on what is the sense of vectors that we are usually taking, okay? And that is why in general we know that vectors is a very important role, and if we know the direction of the vectors, we can actually find out the resultant, and then based on that we can actually predict a lot of cases. For example, let's say some of the common numerical problems are, let's say you are moving in rain and the rain direction is given, okay, and you are moving in certain direction, and then what is the resultant effect. So those kind of ideas or those kind of concepts can actually be solved using the idea of vectors, okay. So eventually we will go to these things, but today, since giving an introduction, we'll just go into whatever we already know and try to know about it, okay. So there are scalar multiple of vectors, yes, scalar multiple of vectors. So you know that if you're basically having a vector which you actually can multiply with any scalars, right? So you have got an A bar plus B bar, and you know that if you just basically multiply it with a scalar, let's say K, we have the distributive law, so we can just simply say that it's A bar plus A B bar, right? Similarly, we have got certain vectors which are coplanar and non-coplanar. So now these things are important, okay, when you actually go for the courses where we actually have a lot of vectors, use of vectors, and non-coplanar. So coplanar and non-coplanar vectors, I think you already know about it. Okay, we're talking about planes here. So in general, if I just draw this, maybe I can just draw a three-dimensional image. Okay, so we can take the three axes here. Okay, and then we can have the z-axis, right? The x-axis, y-axis. So if you have a lot of vectors here, you have one vector on this direction, one vector on this direction, one vector here, okay, one vector here. All of them are in the same plane. That means they are in the xy plane, right? So all these vectors that we have, maybe A, B, C, E, all of them are coplanar vectors. Okay, so all of them are coplanar vectors. Here, on plane, let's say this is E. And we can simply say that E are non-coplanar. Okay. So if I'm giving you a problem and I'm trying to actually solve certain things, if this idea is clear, you can just look into that kind of problem. Okay, so I'll just show you to these things. Okay, we're going to look into these things in more detail later. Okay, so this is about coplanar and non-coplanar vectors. So whatever example we have seen in the previous slide, all these are actually nothing but based on coplanar vectors. Okay, so these are coplanar vectors. So next, is something which you already know about unit vectors, okay, and then probably we'll do some sums on unit vectors today. Okay. So a unit vector means that the total magnitude is 1. Okay. So in general, when we actually represent a vector, okay, this length I really don't know, okay, but this will be in terms of the unit vector. How many times this particular direction, if I say it's I cap, and this particular, if I say j cap, this cap will actually represent it's a unit vector, and then if the magnitude of I cap is, let's say, 1 unit, right, and this particular length is how many times this particular unit, right? So maybe this is around 2.5, so I can just simply write it down as 2.5 I cap, and maybe this is the unit vector in the y direction, okay, and then we can actually write it down as 1.5 times of j cap, right? And then when I write down the resultant vector, we can just say that it is 2.5 I cap plus 1.5 I cap and so on. Okay, so this is the idea of unit vectors, which we already know. And then if you have a vector and if you want to find out a unit vector in the direction of the resultant vector, you are actually going to use this particular concept. Okay, and then we have got something which is also called a component of vector. Let me write down this. Okay, this one, component. Okay, component of vectors. Okay, so in general, if I basically just write down a vector, let's say v bar, okay, and then it has got a component, let's say x, vx in the I direction, and then we have got it in the y direction, okay. This is j cap, and then we have got it in the z direction, okay, and let's say this is k cap. So these Vx, Vy, and Vz are the components, and I, J, and K are the direction of those particular components. Okay, so this is something which we again know. But then these component vectors might also make certain angles with each other. Okay, and for this, I'm just going to draw this particular figure. Okay, and okay, this might take some time. Okay, let me just draw this first. So I'll just draw the x, y, and the z axis for you, x, y, and z axis, okay. And then we can just draw. So maybe I'll take this, or I'll try to make it a bit better. It's more three-dimensional, so I'm just going to do this. Okay, drop it here, and maybe I can just drop it here, drop it here. Okay. Something which is parallel, let's say. This will actually help me to get a clear picture. Maybe something like this. So I have drawn the axis, and then I have drawn a cube here. Okay, and then I can actually have different vectors along x, y, and z direction, right? So if I just draw this, okay, maybe this is the y direction. So I just write down v, y. This is your x side, maybe x, and z direction. And that should just have this around it should have drawn it. Origin 2. This is my origin 2. What I can do is I can join these two. Okay, maybe I can use a different color. This is the resultant. Okay, this is the resultant, and let's say this is V. This is my V. As I was saying that I want to just go from O to E. Okay, so let's say I've just written this as OE, and I can go from O to E in three different ways. What I can do is I can go from O to A, and then I can go from A to B, okay, and then probably I'll go from B to E. This is the path that I'm going to follow. Go from here to here, I'll go from here to here, and then I'll go from here to here. Okay. So these three day and day complete. Okay. And if this we just break it up, we know that we got the components of the vector. Okay. But then we have to understand that if we just consider this component of the vector in a way in certain angles with the vector.
So it's lagging again.
Yes, sir.
Anyway, I don't need to self-explanatory. Okay, if you just look at this, so this is cos of the angle between B and X. Okay, so you can take the component
So again, your voice is not clear.
not clear. The question says that find the equations, okay, sorry, equation of a straight line, okay, which passes through two given points A and B, having position vectors A and B. Okay, so A and B are vectors. Okay, with respect to an origin. So what you have to do is you have to find out the equation of a straight line. Okay, so passes through two given points A and B, okay, and having position vectors A and B with respect to the origin O. So maybe I can just write down this as vectors here. These are two vectors. One vector, this is this other vector. Okay, so what happens in general that we say that two given points A and B, and if we say there are they are on the same plane, okay, that means they are coplanar. But if you are considering 2 points on the same line, they are collinear, right? So some technical terms which you studied in class 11, 12. If they are on the same line, it is collinear. If they are on the same plane, it is coplanar. Okay. So whenever you are going to explain such problems and going to define it, please do mix up the terms. Okay. I think that's important. Okay. Because if you understand it clearly, it will be more easy for you. Okay. So what I can do is probably I can give you a hint here, okay, on how to solve this particular problem. So you have to find out the equation of a straight line which passes through two given points A and B, having position vectors A and B with respect to the origin O. So if you remember yesterday, I did tell you about position vector. If we have got, let's say, an origin which you can choose on your own will, and you actually drop a line from that origin to a particular point P, okay, that will actually give you the position vector. So let's say I've got an origin O, and let me just drop a line on this particular point, let's say, and let me just draw another line maybe here. So according to this particular question, you have got 2 points A and B. So this may be the point A, okay, and this may be the point B, and it is dropped from the origin O. So I will take up this as O origin, okay, and then these two position vectors are basically A bar and B bar. So I'll just take up this as A bar and take up this as B bar. You have to find out the equation of a straight line which passes through these two given points A and B. That means you have to find out the equation of AB. So if you just take this straight line, yeah. So this equation, the equation of this particular line is something which you have to find out. Okay. So that's the question. So once you read the question, you have to just try drawing it. So this is the first thing that you should know, which is basically coplanar. So what do you mean by this? Because they are lying on the same line, that means n times, let's say AC, okay, is equal to n times CB. Now see into this equation, this actually makes perfect sense. So if I just ask you to write down the equation of a straight line, you can write down different ways, different forms of it, okay? But I can also ask you this question, find the equation of a straight line which passes through a given 2-point and this with respect to origin O, or I can say, show that the equation of the straight line, okay? If I just replace this, show that the equation of the straight line which passes through the two given points A and B, the position vector A and B with respect to the origin O is, this is the final expression that you might get, okay? R is equal to m times A bar plus n times. We are not really solving this problem, okay? We are really using vectors here to understand the problem. That's it, okay? So right now, don't worry about solving this correctly. This is R times m times A bar plus n times B bar, okay, divided by n plus n. Now this is different, okay? Now this is something which only talks about m and n, okay? So you know what is m here and what is n here, okay? So this might also be given in the question. AB and CB are coplanar and m times of AC is equal to n times of CB, okay? Now think about it and try to solve it, okay? So the approach is more or less the same. The approach is more or less the same. What we say is simple. Let's solve it into it. Okay? Let's say O A bar. So we go from O to A, and then we can say we go from A to C. We go from A to C, and this will be equal to OC bar. Right? So this is simple. Now we have to follow the diagram and then do it. You can use any other notation, no problem. A is nothing but A bar, okay, plus AC bar is equal to R, right? Plus OC is R bar. Okay, so that's it. From here, what we can do is maybe we can write down what is AC bar. AC bar is equal to R bar minus A bar. Okay, so we have an expression for AC now. Because you know we are using m times C is equal to n times CB, so we have got AC. Now let's try to find out what is CB. Okay, so for CB, what we can do is this. Maybe we can write it this way. There will be other ways also. What I'm thinking right now is this: OA plus AB is equal to OB. Right? So OA. Now what is OA? OA is A. Okay, is equal to say AB, oh sorry, plus it's plus AB bar is equal to OB, so it's nothing but B bar, right? So we can say that
Yes, sir, I have
AB
done
bar,
it.
you've done it, right? Okay, good.
Yes, sir.
So let me just show it to others. Okay, first class, so I'm not putting in pressure. Next class onwards, probably I'll ask everyone to just share their answers, then I'll check we're getting it right or not. Okay, then what is OB? But OP is equal to R. So you know OP can be taken as R plus CB. So R plus CB. Okay. Or we can say CB is equal to, everyone should pay attention here, minus R, which is OB bar minus R. Okay. What is R? R is nothing but, or we can just, maybe we don't need to place R here. Okay. B, so B is B minus R. You can just put it as B bar minus R. Okay. Now we can just list everything. What we have here is M into AC. M into AC is R bar minus A bar. R bar minus A bar is equal to n into CB. So n into CB we have just found out to be B bar minus R bar. Okay, so you can directly just do this, okay, and then do the sum. It's not a problem. There may be different approaches. Don't worry about it, and just try to simplify it. And when you simplify it, you should get this relation: m a bar plus n b bar divided by m plus n. So this is the equation of the straight line. Okay. So I'm not explaining so much theory of vectors. If you do some numerical problems, I think it will be much more easy for us to revise vectors. So this is obviously nothing but revision. Okay. So you try to solve this problem in this way. Okay. Let me just one final problem. Okay. Let me just take one more problem here. Maybe find the unit vector. Unit vector problems, you might have done it. Let's just do it anyway. Parallel to the, say, resultant of vectors. Okay, this time I have to write resultant of vectors. So there are two vectors. Let's say R1 maybe is equal to 2i plus 4j minus 5k. This is one vector. And then we have got one more vector R2. This is I plus 2j plus 3k. So there are two vectors which are given here, R1 and R2. You have to find out a unit vector which is parallel to the resultant of the vectors. Okay. So what you do is find out the resultant first. Okay. And then find out a unit vector parallel to it. So this is a problem which you might have done a number of times if you had maths in your undergraduation. Okay. Plus 6j cap minus 2k cap.
By 7.
7. Okay. So this should be your unit vector. All of you should do it. Okay. We'll just write it this way. Okay. So try doing it. Okay. All of you should get a similar answer. You know that basically, if you want to find out the resultant, this is nothing but R1 plus R2. Okay. And you can find out the resultant vector here. Take the magnitude of this, and then that will should give you 7. Divided by 7. You should get your answer. Okay. There's certain problems which we actually need to do. Okay. And okay, let me just give you one more problem, and this you may take it as homework maybe. Let's see. Try this. Prove that vectors 2i. Okay, I'll just type it plus j minus 3k, okay, and then comma I minus 4k and 4i plus 3j minus k are linearly dependent. So you have to prove that these three are actually linearly dependent. So individually if they vanish, we know that they are linear dependency or independency. Okay, and if they are linearly dependent, you can actually find out the values. Like for example, if you have two vectors, let's say R1 and R2, if they are linearly dependent, okay, we can say that A times of R1 plus B times of R2 is equal to 0. Okay. So in that way you can actually solve, and you can also find out what is the constant A, B, and C, and so on. Okay, so you can just refer to any notes and all that you have, and then you can try to solve it. So this is something which I will just leave it to you as a